Morning class. My name is Mr. Sgauke, and today we are going to look at probability for the syllabus component 0580 commerce. Now we are going to define probability. Probability, as defined here, is the likelihood of a chance of an event taking place, right? The likelihood of a chance of an event occurring or taking place. Now, we look at experimental probability. Now we are saying, if you, let's say you toss a coin, or you look at the month of January, you find how many times has it rained in the 31 days of January, right? If it rained 5 times, then the probability of it raining in January then becomes 5 days that it rained over the number of days in the month, which will become 5 over 31. So the probability is the number of ways of achieving success over the total number of possible outcomes. So in this case, the number of ways of achieving success is the number of days that it has rained, and the total numbers that are possible, the total number of days that it is possible for it to rain are 31 days, right? So here we have the probability of flipping a coin. A coin has got two sides, a head and a tail. So the probability of it landing with a head or landing with a tail, those probabilities is equally likely that it lands with a tail. It's also equally likely that it will land with a head. So the probability out of two sides of the coin will be, for it to land with a head, it will be 1 over 2. The probability for it to land with a tail will also be 1 over 2. Right? Now, some things are certain to take place. Definitely take place. Like the probability that the sun will come out will be, it's certain, it will be 1. Right? Probability ranges from 0 to 1. So 0 is the probability that an event is unlikely to take place. Right? The probability of something which is impossible to happen. The probability of something which is certain to happen is 1. The probability of something which is impossible to happen is 0. And the probability of something not happening is 1 minus the probability of it happening. So these probabilities, the probability of something happening and the probability of something not happening complement each other. Now, right, this is an example of a single event, probability of a single event. This is an example that we have on the board here. There are 6 beers in a bag. 3 are red, 2 are yellow, and 1 is blue. What is the probability of picking a yellow? Right? We now look at the number of beers, the number of beers in the bag. We have got 3 red, 2 yellow, that makes them 5, and 1 blue, which makes which brings the total to 6. The probability of picking a red will be 3 over 6. Right? Since we have got 3 of them out of 6 inside the bag, the probability of picking red is 3. The probability of picking a yellow will be 2 over 6. And the probability of picking a blue will be 1 over 6. Right? So the probability is the number of picking a yellow is the number of yellows in the bag divided by the total number of balls, which gives you 2 over 6. Alright? So if we increase the number of blue balls to 300. Okay, let's look at another example. There is a bag full of colored balls, red, blue, green, and orange. Balls are picked out and replaced. John did this 1,000 times and obtained the following results. Number of blue balls picked out 300. Number of red balls 200. Number of green balls 450. Number of orange balls 50. This total should add up to 1,000. Alright? Then the question says, what is the probability of picking a green ball? There are 450. There are 450 green balls out of 1,000 balls that are inside. So the probability of picking green, P green, right, will be equal to 450 over 1,000, which is 0.45. And remember, probability ranges from 0 to 1. 0 being the probability is uncertain for that event to occur. And 1 is the event is certain to occur. So the moment you get any other probability which is outside the range 0 to 1, then you must be suspicious of your answer, and then you have to go back to your working and revisit your working and see whether you didn't make a mistake. If there are 100 balls in the bag, how many of them are likely to be green? So the probability is that we now have reduced the balls from 1,000 to 100, but the probability remains the same. The probability of picking a green ball will be 450 over 1,000, which is 0.45. So if there are now 100, the frequency now of the green balls, of the number of green balls inside the bag with 100 balls should be 0.45 times 100. It should now fall from 450 to 45. Right? After multiplying 0.45 by 100, you get 45 balls. So the experiment suggests that 450 out of 1,000 balls are green. Therefore, out of 100 balls, 45 are green. Using ratios, you are using ratios. You can even use proportion. That if in 1,000 there are 450 green, in 100 how many greens are there? Then you find that there are less greens. Then you have to divide the smaller number over the 1,000. Then multiply by the probability. Now we need to look at more examples on this one here. Let me go to the board. All right. Let's look at an example from the book. Right, a bag contains 3 white discs and 5 black discs. One disc is taken out at random. What is the probability that it is A, white, B, black. Now, suppose the discs are in this container here. The white ones are 3. These are 3 white. And we also have 5 black in there. These are 5. The 5 black. Right. Black, white. Now, in total, the probability space has got 8 discs. We write that, we can write n standing for the number. We have 8 in there, right? The number of white discs, n white, and this is the notation that we usually use. Number of white is now equal to 3. Now to find the probability of having white, probability white is equal to number of white over the total number. And this is the number of white here is 3, and the total number of discs is 8. So this is the probability of having white balls. The probability of having black balls can also calculate the probability of having black balls. The number of black balls in the is 5. We have 5 black balls, and we have got 5 black balls. So the total number of balls is equal to 8. We are now calculating black. Black is equal to 5. Probability black is equal to 5 over the total number, right? Which gives us 5 over 8. Notice that the probability of not having black balls in the bag, is written as the complement, which is written as P probability, like that. This here shows the complement, which means we are now saying what is the probability of having black balls in the bag is 5 over 8. The probability of not having them is equal to 1 minus 5 over 8. We can convert this 1 to 8 over 8. Then we subtract 5 over 8, which gives us 3 over 8. We can do the same for the probability of having white balls. We are saying the probability of having white balls is 3 over 8. What is the probability of not having white balls? We subtract, we say 1 minus 3 over 8, we get 5 over 8. And the probability of not having, white plus probability of not having white should give you 1. Just like we are saying 3 over 8 plus now 5 over 8 should give you 8 over 8, which is equal to 1. They complement each other. So the probability of it raining in January, if it is 5 over 31, then the probability of it not raining in January will be 31 over 31 minus 5 over 31, which gives us something like 26 over 31. So we're expecting January it to rain 5 days and not to rain 26 days out of the 31 days in January. These probabilities, they complement each other. Right? Let's do one more example. Right, let's do one more example. Example 2. Nine counters numbered placed in a bag. Or placed in a bag. One is taken out at random. A 5. B divisible by 3. C less than 5. D divisible by 3. All right, 9 counters. 9 counters numbered 1, 2, 3, 4, 5, 6, 7, 8, 9 are placed in a bag. One is taken out at random. What is the probability that it is a 5? A 5. Less than 5. This is divisible by 3, divisible by 4. Now our probability space has got 9 numbers. The number in the, it is with 9, right? This is the probability space. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements, right? Now, to calculate the probability that it is a 5, we just have the number of elements that are 5 is 1. We just have 1 5. So the probability of having that 5 is the number of 5s in the probability space over the total number of elements in the probability space, which gives you 1 over 9. Right? 1 over 9 becomes the answer for that one there. And then divisible by 3. Divisible by 3, we are now looking at all numbers that are divisible by 3. Is this one, that one, and that one. Right? And the number of elements that are divisible by 3 and divisible by 3 is equal to 3. Probability now, we are now calculating the probability. Oh, here I'm supposed to write it like that. N divisible by 3. Probability divisible by 3 is equal to number divisible by 3 over the probability space. And how many do we have? Right? We have got 3 elements that are divisible by 3, which is 3, 6, and 9. So 3 of them out of the total, which is 3 over 9, which if reduced to the lowest term becomes 1 over 3. Right? Do the same for less than 5. We look at the numbers that are less than 5. There are 4 of them. These are less than 5.